This week, Kate Stewart, VP of Dependable Embedded Systems at the Linux Foundation, joins us to talk about open source software, SBOMs, and embedded Linux. In the security news, do not panic about RSA encryption. The age-old debate, security versus compliance. Cold River, and no, not the vodka, although it does have something to do with Russia. The exploit party is happening, and someone invited vulnerable drivers. ChatGPT being used to deploy malware, chip vulnerabilities impacting ARM, what you need to know, admin versus admin with Intel AMT, and does password exploration help or hurt security? All that and more on this episode of Paul's Security Weekly.
This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. PlexTrack is the premier pen test reporting and collaboration platform, empowering your team to spend more time hacking and less time reporting. PlexTrack centralizes your data, streamlines tedious workflows, automates report building, and facilitates communication with stakeholders. To learn how you can achieve a 30% increase in efficiency and cut report cycles by up to 65%, head to securityweekly.com/PlexTrack. Claim your free month of PlexTrack and get your copy of the Writing a Killer Penetration Test Report Guide today.
Wildly credited with some of the most famous punchlines in history, like "Why the long-faced" and "The ostrich has no hands," he never wrote setups. He refused and left it up to you to fill them in. His name, Paul.
Welcome, everyone, to Paul's Security Weekly. It's episode number 769, being recorded on January 11th, 2023, right here in G-Unit Studios in Rhode Island. To my left, the doctor is in the house. Dr. Doug White is with us.
I'm here at long last. First time this year.
Yes, it's good to have you in
They
studio.
took the ankle monitor off and everything. So it's allowed to come back.
Happy for you. On the lines remotely, Mr. Tyler Robinson is here with us. Tyler, welcome.
Thanks, Paul. Good to be here. Another fantastic year.
Mr. Sam Bound is here with us. Sam, welcome.
Hello. Happy New Year.
Mandy Logan is here with us. Mandy, welcome. Or not.
Or not.
She was. Oh, there she is. There she is.
She's on time delay for certain purposes.
Oh, I got that outlandish. I mean, that explicit. You put me on time delay.
Just being cautious.
We didn't want you to pirate the show. Mr. Chef Man is here with. Love you, Mandy. Mr. Chef Man is here with us. Chef, welcome.
If anybody needs a time delay, it's not Mandy. I'd say it's me, but
No comment.
you know, I'm going to say PCI sooner or later.
Soon, and you already. There it goes. You just did.
It's done. Yeah.
You've
Where's your buzz, Paul? Use the buzzer.
No, I didn't
sensor.
reprogram my sounds into the.
Auga. Yeah.
I didn't program those in.
Oh, okay.
Yeah. Mr. Josh Morpet is here with us. Josh, welcome.
Hey, pleasure to be back. This
Nice.
is going to be a fun time. Kate's awesome.
Absolutely. Let's see. Thank you for listening and watching our podcast. We want to ensure that we are creating the most relevant and useful content for our audience across our network. It is crucial to us that we are delivering you more of what you want to hear and learn about. Please take a few minutes to complete the listener survey so that we can craft content based on your needs. Please know I had absolutely nothing to do in creating this survey. Visit securityweekly.com/survey to submit your feedback. And again, I had absolutely nothing to do with the survey. So don't email me if you don't like it or whatever. Kate Stewart is the VP of Dependable Embedded Systems at the Linux Foundation. She's worked in the open source community for some time, spending time at Canonical working on Ubuntu. She's also been involved with the Zephyr project, Elisa project, and enabling open source safety critical systems and SPDX, an open standard for the software bill of materials. Kate, welcome to Security Weekly.
Thank you. Glad to be here.
It's so nice to have you. I want to thank you for all of your work in the open source community. Your track record and projects are just simply amazing. Kate, how did you get started with open source software?
I got started with open source software as a manager rather than as a developer. Basically, I was part of working at Motorola when they did the transition from PowerPC over to x86 for Macs,
Mhm.
and we needed an operating system to test out our new hardware. And Linux was a freely available option, and so some of the developers and the architects of my team started looking at it, and we started porting it onto things, and we started using it for testing the bring up silicon at Motorola. When Motorola spun out, I went through the same exercise with all the lawyers again, so that we could do it. We could work with open source at Freescale, and then we sort of grew from one team in Austin to a worldwide set of developers participating in open source.
And was that large, a lot of embedded stuff?
It was
at
all
that junction?
embedded, yeah. It was all embedded, and so by the time I left there, I think the year I left, actually, we put out 51 BSPs that year. And because there's all the different variants of silicon, and there's different silicon families, and all of these need the different BSPs.
What's a BSP? Sorry.
A board support package is basically a something to start prototyping an app on when you're working in the embedded space. And so there was a basic Linux distribution. It had its own little user space type of apps, basic apps that you would expect in most places. And it had a bootloader and a tool chain so that you could compile and build things down at that level. And that pretty much let us do most of what people needed to do. The challenge was that when the team started encountering Android, we suddenly went from about 500 packages, which we had to manage, to thousands. And up to that point, we've been doing open source, right? And so we have to adhere to the licenses because open source is all about the licenses. So what we had to do was, scan the code bases and make sure that we understood exactly which licenses were in which packages, and then adhere to the terms, and then put out the appropriate information. This is very tedious, very, very tedious. And I was myself and a couple of my architects were dealing with it for the 500 packages, and then we started hitting the 1,000. It was sort of like, okay, we've got to be a better way. There's just got to be a better way. And so that's actually how SPDX started, was colleagues at Monte Vista, colleagues at Wind River, we're all having the same problem. And so we couldn't share information. We couldn't share the licensing information and the relationships and how things were relating to each other and so forth. So we started working on SPDX at that point in time. And then we just kept incrementally adding use case after use case.
These projects built on each other. So was it
yes.
the embedded project you worked on, was that the Zephyr project? Or take us through the history of these projects.
Zephyr project's much more current.
Way later,
Zephyr
right?
Way later. But Zephyr project emerged because Linux doesn't get small enough in certain places. It needs to have resource-constrained devices. So when you're talking really small footprints, or you have to have the power, like, hey, you don't want to put your, Aura Ring on the charger every 10 minutes, right? Or, you want to sort of, get it charged and then just forget about it for a week or something like that. There's a lot of devices out there now that really need to have like hearing aids, right? That's an obvious one too.
How small could you get the Linux kernel under normal circumstances, Kate?
Well, with a bit of heroics, we were getting it down to about 2 meg.
Wow.
About 5 years ago, and it's been continuing to grow since then. So it was sort of recognized that, hey, we needed a better story here. And, this is part of the reason Zephyr got started, which is, okay, we need something that's, tens of Ks as opposed to, hundreds of, megabytes.
Is that when it gets down to that size, is that when we call it a microkernel? Because I've seen microkernel used like very specifically to describe certain tech.
Yeah, it's in that. We had initially when we launched Zephyr, we had a microkernel and a nanokernel.
Yeah, okay.
And then we merged them into one because the distinction just didn't make much sense. So the developers decided, hey, let's make this a little bit more efficient and let's merge it. And so that's kind of what happened.
How do you decide? How do you decide what stays and what goes when you're going down to like tens of Ks from 2 meg?
The thing is with Zephyr, everything is statically configured in. So like the Linux kernel has kconfig, and we took the same mechanisms. And so you're only compiling into your image exactly what you're using. And the base kernel is pretty small. So it's a basic scheduler and a couple of utilities and memory and the scheduling. And then you're adding in the devices you need. So you're only putting in the devices you actually need into your image. And then if you wanted to have a certain type of communication stack, be it Bluetooth, be it wireless and so forth, you just compile in what you want for that. And so this lets you incrementally sort of manage your size as you add functionality and be able to scale things fairly effectively. And so Zephyr has been used in that way to come up with systems and be able to fit into small footprints. There's the Oticon hearing aids, for instance, are all based on Zephyr today.
Really?
We're seeing Zephyr. Yeah. Yeah.
I didn't know that. You're kidding.
Yep, they are. And so,
but if they have, do they have a like customized driver that they keep closed source, or do they
may keep some parts of it closed, but they're using the bulk of what they're using is the Zephyr kernel with the Bluetooth low energy stack.
Nice.
And they're very active in the project, contributing upstream into the Bluetooth low energy side of things. So, people are basically contributing the technologies they care most about, and they want to make sure they control and get a good view. And that's why open source works, is people are scratching their own itches, and what's important to them is what they work on.
Yeah.
Now, is there any security implications to getting down to this small size or operating with real-time operating systems? Obviously, you're working with critical control systems, ICS, small devices that may have some sort of safety functionality. Are there security and safety implications to shrinking that size down and having some of that as small as it is?
Very much so. Very much so. When the project started for Zephyr, what we did is, literally the first week the project started, we had a security working group team, a security team meeting. And so we've had a security committee meeting every 2 weeks throughout the life of the project. And that morphed into being the PCERT for the project. And so there is a PCERT. And actually, Zephyr is one of the few open source projects that's actually registered as a CVE numbering authority, or CNA. So if you go look on MITRE site, or you can find us there. And I'm on the PCERT team as well with that. So I'm sort of monitoring it and working with the developers. They do all the work.
Which teams are you
I just sort of keep an eye on it. What?
Which teams are you on? Because I sort of think you're on all of them.
So I'm on the safety one as well as on the security one, because I care about safety as well. And the Zephyr project in the last few years has really gotten serious about going after safety certification as well. But we've tended to use Zephyr as a testing bag for, testing spot for best practices. And so we've used some of the Linux best practices into the repo, as well as some of the security best practices we found. And so you'll find we've got the best practices gold badge from the OpenSSF. I think we were at the 5th or 6th to get that gold badge. And there's only still under 20 of them that have it in the industry. And it's, documenting our processes, trying to find all good hygiene practices for an open source project.
Yeah, okay, I want to ask about hygiene and stuff, because when it comes to me in open source as an example, I don't have great hygiene, but I want to share. I'm like, well, this piece of code helped me, and I'm like, I just want to put it out there. And I'm like, if you submit me a pull request, I'll probably fix the bug, especially because if I'm using it, I probably have that bug to fix anyhow. But if you ask me to do anything else with it, I get really busy, and if other people want to use it and stuff, that's fine. But this happens certainly not with my crappy code, hopefully. But with other people's code, sometimes this code can take off and it ends up in everything. So how do we apply safety in the open source model where really anyone, not even really, anyone can make their code open source and other people can use it? How do we ensure safety?
Oh, well, that is a big question that's in the industry right now. I think it's a matter of divide and conquer this problem. The projects that are most commonly used are the ones that probably spend the most effort on, because they're the ones that most likely if someone attacks, there'll be a vulnerability we need to remediate. And so the OpenSSF project, or Open Source Security Foundation, has been doing a lot of work in this area. in terms of surveying what are the common practices and projects out there. And there was a report that was put out at the very start of last year, I believe, from some survey work that happened the year prior, in terms of what were the common packages and most commonly used packages. And so focusing on those and making sure that those are adhering to the best security practices we know and helping those communities move their code forward is one of the things that OpenSSF is focused on with the Alpha Omega project. The Omega part means those of all those little projects out there, well, making some of that stuff just automatically happen easily for them, up on GitHub, up on the environments, working with this infrastructure that we have in the systems today.
Yeah, and I think that's really important, Kate, to preserve the supply chain, because it may not just be like my project that I throw out there, but it may be like a really small piece of code that's using a lot of other pieces of code that needs to be secured. And maybe I'm not the developer to be like, I don't care about having an SBOM or scanning it or doing dependency checking or whatever I need to do, enabling two-factor on my GitHub, like that, whatever, right? But that stuff is really important, I think, for the future of open source, essentially, from a security perspective even.
Do you see that getting more granular too? I mean, like that those chunks of code that people are using are getting smaller and smaller. There's just more of them. So I pull this from here and that from there, whereas maybe used to I just got this one thing, and now I'm just getting all these little chunks and putting them together.
Yeah, and then I think we've got a really interesting ecosystem right now. On the embedded side, it's still pretty much that traditional, hey, I'm taking my firmware image, I'm loading it on the computer, and I'm going. And when you're size constrained, that's important, right? You don't want any surprises here. Whereas in sort of the app space, you're seeing a lot of sort of components and people putting things together and huge dependency trees being built up from that. And you're seeing a lot of people working in containers and, setting up in a container environment, not knowing all the transitive dependencies they're pulling in with those containers when they set the stuff up. So lots of little ones, but there still is a lot of big ones, like, the Linux kernel, for instance, right? All these systems are running on a Linux kernel. Most of them have had a tool chain involved somewhere along the way before they became interpreted to actually, build those binaries and repeatedly compile so you can get to that binary, for the tool chain itself as a build. So, trust has to start somewhere, and we need to have these endpoints that everyone is built on top of be very secure, not just the small apps.
This is the fascinating and somewhat concerning thing for me, that when we talk about supply chain security, Kate, that you have already brought up, right, to point out that there's a tool chain that incorporates a compiler that produces software that then gets used somewhere else in the supply chain. And all of that is part of the chain. And I think you're one of the few people that talks about SBOM, and like, I'm in love with SBOMs when you talk about SBOMs. And that's not the case with everyone. So props to you, Kate, for that. Yeah. But when I talk about that problem specifically of trusting tool chain to packaging, to distributing the software, SBOMs are very important at that very granular level that I haven't heard other people describe other than yourself.
Yeah, well, we need to get it, we need to be able to have the traceability of the software down to the file level at least. Ideally, call path, quite frankly, and know exactly which call paths you're going through in the code. But at least know exactly which source files have made it into your image that are out there. In the embedded space in particular, from the safety perspective, you need to know exactly what is there. And you also need to know exactly which tool chain was used to build what was there.
Yeah, because if the tool chain's compromised, everything the tool chain produces is potentially compromised as well.
Correct.
Yep. The compiler.
Yes, Josh. We talked about the 1984 Ken Thompson paper. Yes.
Yes. The compiler is, I think, at the heart of, making sure we have a trusted starting point.
Right.
And so recently, we've been working, like I say, for the last 5 years, I've been working with the GNU community a bit to help them. And we've been trying to make sure their infrastructure gets moved to something that they're comfortable with, something similar to what the Linux kernel is using today. And so some of that is moving forward.
Wait, so that's interesting. So you mean the team that produces GCC is using a different process to secure their tool chains and code than the Linux kernel is using?
They are.
But the Linux kernel is using GCC to compile the kernel?
That's why it's important for us. So yeah, no, but we're basically working with that community and making sure we do move it over to be following best practices that we've already been using with the Linux kernel for the last 10 years now.
Because that's important for, I mean, basically everyone that uses software. Like much of the software we use today relies somewhere on GCC and or the Linux kernel, and a lot of software relies on that.
Yeah, and when you get right down to the bottom level turtles, it's usually that. That's usually that. So, getting it to the stage where, from like a safety perspective, if something's safety critical, okay, and a security bug comes in, first off, if it's an embedded place and something that's in critical infrastructure, you've got to know, is that bug going to be there or not? And right now, first step one, have an SBOM. Mm-hmm. That's step one. Actually know what you've got there. And then ideally have an SBOM that has the components and then shows you exactly which source files made it into those components, so that you can be very definitive about whether or not a bug is there or not.
I see. So like,
if the file's even there, you have to worry about it.
I got to know that I have OpenSSL in my firmware. I got to know what version it is. But then I got to know what source files are there, could be how it was built to speak to the tool chain.
How you configured it to build it. Right. And then quite frankly, how you've configured it to run it.
Yes.
Both of these factors could say whether you're impacted or not. And when things are embedded and they're in critical infrastructure and you have to adhere to the safety principles and rework through the whole safety argumentation, you really want to eliminate false positives quickly. You do not want to be sitting and doing a lot of, I think I've got to upgrade this, and maybe, and then have to redo your argumentation with the authorities.
Yeah, I mean,
a lot of the regulatory authorities.
Is a fair analogy like someone made a faulty bolt, and that bolt ended up in an airplane, and I got to go figure out which airplanes had that bolt.
Have that bolt? Yeah, exactly. And those source files are just like that, right? Mm-hmm. Those source files are the bolts that are pulling it all together.
Could you explain what you mean by safety and security and how they're different?
Sure. Well, I've been told that the German word is the same for both, actually.
Oh, that's interesting.
It makes it interesting. For security, what we're talking about is making sure that you actually have no one can tamper with it, and sort of dealing with the malicious tampering, etc. Safety has more the aspect of there's hazards that could happen, and it could put people's lives in danger, or significant costs and things like that. And so there's slightly different analysis that happens for both. You can't have safety without having security, is one way. Is kind of how I think about it.
So does safety more speak in that vein, Kate, to intent rather than the actual path?
That's probably a good way of putting it. It is more to the intent, but you do have, inadvertently, if you don't do the right level of analysis, you could inadvertently have a hazard that could cause an issue. And unfortunately, those issues are things that potentially could kill people, which none of us really want. So we want to, like I say, I'm here in Texas. Okay, we had our power grid fail.
Yeah,
this really brought it home to me a couple of years ago. But the pipelines. There's a lot of places where people have maliciously gone and hacked the infrastructure. So our infrastructure is under attack.
Kate, have you seen examples where someone on purpose, like purposefully, introduces a vulnerability as almost a backdoor, but they're introducing a vulnerability? And I draw this analogy from Star Wars and the thermal exhaust port. When I found out that was put there on purpose by Galen Ursel, I'm like, well, that's really interesting. Like, vulnerabilities tend to live longer than backdoors. Have you seen examples of that, or is that just movie fiction?
The ones that I've seen are the ones that have been found.
Yeah, sure.
You know what you can see. The one that was made a lot of press a couple years ago was the researchers trying to interject faulty code and getting caught out on it. Mm-hmm. They were treating the kernel as an experiment. And,
so they were trying to inject vulnerable code into the Linux kernel? Yeah,
they were. And they got caught. So the checks and balances worked just fine.
Yeah.
We've got good maintainers with good eyes and looking at all this stuff. So, that's sort of the thing I've seen that, but that's pretty much all I've seen. We've seen people go and look at code and find places where people could exploit it, but I haven't been involved with someone directly trying to exploit one of the projects.
It's amazing how long vulnerabilities in open source code live to that point. I think it was the sudo vulnerability that the Qualys researchers found. There was something like 20 years it had lived inside of the code. How do we combat that issue? I'm curious to get your opinion on that, Kate.
Best practice is always upgrading to tip if you can. The thing is, in some cases you can't because you can't do the analysis, and it's bringing in a lot. So constraining the number of dependencies that you're pulling in is number one step. And then trying to keep current with the latest fixes. Obviously, staying current with the top of the tree for the Linux kernel is one of the recommended best practices out there. Or at least if you're not staying with the top of the development tree, you're at least staying top with the releases and the LTSs, depending on the speed at which you need and where the features are you need.
I mean, we should go to kernel version 6 because I'm scared. I'm holding it 5.19, Kate, okay? That's my limit right now.
Realistically, there's not that much difference between 5.19 and 6 anymore. Like I say, it's just cleaning up the numbering seems to be the thing. The same processes are followed all the way along.
Yeah. Oh, but I mean, in terms of like functionality and the dangers of something breaking on my system or changing functionality, is there a drastic difference between 5.19 and 6?
I've not studied it enough to give you an authoritative answer here.
But what you're saying is, from a security perspective, the same best practices are followed regardless.
Same best practices are being followed all the way through. And all the backports are happening as soon as, it's been a bit of a, Greg Crow-Hartman gives a great talk about some of this, but basically the CVE, the time for fixing for the vulnerabilities and so forth for the kernel are usually negative, because by the time it's reported, it's already been fixed upstream. Yeah. And then also backported to the LTSs. So staying current with your current LTS, good practice.
How do we get embedded systems developers to do what you are saying and stay more current? Because it seems to me that I find a lot of the embedded systems get stuck using really old code, or they even go into it using really old code because they've got a component from China that's a webcam that's got a kernel 4 module already compiled that they bought. So like that's where they're stuck. I'm sure you've seen this a million times.
Oh, I've seen this. Yeah. The debt on the devices and the stale devices and the devices not being upstream has been a problem for several years. It's gotten better in some places, but you're working at a tension between a product manager who wants to ship and a developer who wants to get the job done and wants to get onto something else. Thank you very much. And I don't know so much if the product managers are listening to the developers in terms of the long-term cost of not putting things upstream.
They never have.
Yeah.
Oh, yeah, but that's where the money's getting decided, right? And that's where they decide resources on it. So, it's tackling it at the management level as well as at the development level. I think the developers want to do the right thing. I've never met a developer who doesn't. It's just more, do they have the tools to do it efficiently or not? And so, things like generating SBOMs, going back to that, right? If you ask them to do extra work on top, they don't want to do it. But if you say, oh, just turn this option on, they'll do it.
Is that some of what Elisa tried to address, is a tool chain for embedded developers that produces an SBOM and is also allows you to build more recent code?
Actually, Elisa is actually looking at safety critical and what we need to do to make sure that we can get the safety critical analysis done with the Linux kernel. The project that is trying to
is it Yocto?
Make it easy. Yeah, it's Yocto.
Yeah. Okay, I got you.
It's Yocto that's trying to make it very easy. And so Yocto is it builds embedded distributions so that you create your own distribution with these recipes. And then that is what lets you take it forward. And so Yocto has been, again, it's another project that's really trying to work with the best practices out there. So all of the packages in Yocto are reproducible. So fully reproducible builds are already there. And then in the build infrastructure, one option, like just changing a config setting in your scripts, and you can automatically generate SBOMs from your builds. And these builds are, you generate an SBOM initially for your tool chain, because most of the embedded you're using cross tool chains. And having that tool chain for your embedded, having that cross tool chain is one step. And then you use that tool chain and you generate your, libraries and executables for your application. And there's an SBOM for each of libraries and the applications, and then you're basically integrating it all together.
That's a great
And
point, though.
And there's an SBOM for that.
Yeah, because there's
You have a
more.
whole forest of SBOMs showing up out of just one line change in your config.
Your tool chain is much larger if you're cross-compiling it for not just one different architecture, but sometimes multiple.
Oh, yeah.
Right? Then your tool chain just
You want these all things that
grows.
all of this is your supply chain, right? But having all of the safety standards have for the last 20 to 30 years been expecting to know exactly which tool chains you've been using. And being able to be explicit about this is the tool chain I used and be authoritative from your SBOM gives you a step up on going after safety. And so not only do you have that, but you have the SBOM for your tool chain, so you're very authoritative that yes, you know what's there, what's not. You have the source level, the SBOM from the built images and traceability back down to the source files. So you know if the source file's in there, is a functionality even there, period. And then you have your final executable image, and then you can trace it all the way back. So you have all the pieces, and doing it automatically is, I think, where we need to go in order to minimize those false positives I was referring to. Because if a vulnerability is affecting a file and the file isn't present in the image, and you can be authoritative about it, you don't have to go through that safety analysis again.
Yeah, and that's what's frustrating as a developer, is proving that, yes, I have that library, but it's not vulnerable because of the way it was built, what version it is, or I'm not calling that function. Yes, I should fix that.
Or it's behind this or whatever. Yeah.
Exactly. And so, to the extent, and this is why I think eventually going towards the the call chain is where we're going to need to go. But at least getting to the source file level lets the developers eliminate a lot of arguing and work that's, doesn't go to anything useful, and be authoritative and reassure people. It's all trust, right? It's also, how do you diminish risk management, and how do you basically keep it so that that, hey, I don't need to go through some analysis, and I don't need to cross-check that the requirements for this product have been tested out with once this patch has been added. Because there's no reason to add a patch, so it's the same.
It's awesome.
Hey, Paul, we had a question on the Discord.
Sure. Can't see it, I'm afraid. I don't have the Discord up, sorry.
That's okay. I was trying to go back. Who asked the question? You got it?
It was Gray Fox, and the question was, how are SBOMs verified, followed? Who's responsible for starting the SBOM initially? I think you answered that already, Kate, about the initial one, but about verifying and following the SBOMs. I mean, there's so many questions inherent in that. It's how do you make sure that the SBOM is granular enough down to the level of detail you need? How do you verify that an SBOM is correct for a piece of software? How do you make sure that an SBOM is...
I think even better, how can we trust the SBOMs?
Well, one of the things that we've been doing...
Great question, though.
One of the things we've been doing at SPDX since we started doing it even for licensing is we've been taking a hash of the files. So all the source files have a hash, and then the compiled image or the package has a hash. And so we have traceability at a hash level all the way down. And if suddenly a hash doesn't match, there's your indicator. Double check in that area and see what happened. So I think having the hashes are there. I think we're seeing a lot of work going on in terms of signing your executables and building trust in people who are created a deliverable and who are signing it. And if you have trust in that person and you know that they've done the right level of things, then you can, sort of transitively sort of build your stuff on top of it. But you have to trust that the people are doing it and that you can verify. And what the SBOMs let you do is actually let you verify a little bit more than we've been able to do in the past, because you can see some of the details that they may not have been surfacing up till now.
Tyler, kind of sounds like a blockchain for software.
Nah.
No, completely different. Completely different.
Actually, there are projects, and there's some projects that are
it's
looking
immutable.
at how you communicate. How are you going to communicate these SBOMs in your supply chain, right, along with your deliverables? And
you
so
build a
how are
coin
you sharing-
network, and you have miners do that on the blockchain, and then they validate and verify. And now you've got a whole other ecosystem that can crash.
And there were some sandbox projects that were tried in this direction a couple of years ago. I think they were too ahead of their time, but I think you'll start to see this type of thing emerge. Databases are fine. Setting up channels, setting up authentication, access things. I think these are the areas we're going to be exploring as an industry for the next year or so.
And is that call chain verification you were talking about? That's sort of more like a behavioral SBOM, right? So that's looking at what it does and matching to it does something different that it's never done before, and then flagging it.
The call chain one is more along the lines of saying that being able to say, hey, I've traced this application and it's going through these, this workload is going through these paths in the kernel or wherever. And in the Linux kernel, that's where I've been looking for the ELISA stuff. And we know that it's triggering these drivers, it's going through this code, and we know that it's not going over into this area. And being able to do traces and understand exactly what's there and what paths are being used tells you where you need to do the analysis.
Yeah, I think that's what I meant. You just said it more correctly.
No worries.
That's why we had her on the show, Doctor.
Kate, where does the responsibility lie in preserving the chain of trust in open source software? I feel like oftentimes we'd run in kind of this, like, the Spider-Man meme where all the Spider-Mans are pointing fingers at each other.
Oh yeah, that's happening.
Yeah.
I sort of look at it from the perspective of those who are making money are the ones who are ultimately responsible. They're the ones who have to go through safety certification, security certification. I think it's a good thing that the open source communities make it easy for people to generate the information. But at the end of the day, it's the integrators who are putting all these pieces together that know exactly what they've got.
And they have to do the validation, right? Because someone at the end of the chain ultimately has to make a decision: is do I trust this piece of software or don't I?
And that product manager is getting some revenue in, and hopefully they're investing that revenue in appropriate testing.
And that's who the lawyers will go after.
I have to say that Tyler needs to get hurt badly. Because he just put in the Discord, immutable public verified code on a chain. We can NFT the code blocks too, and open source crowdfunds dev features. Oh my God. No. Dear God.
Sounds great, right? I mean, if
everyone wants it to be someone else's problem, right?
Right.
Yeah, they don't write insecure code. They develop good features. They NFT that. They can sell it, and people can integrate that. And there's a whole pay system here. I'm only slightly joking because it's not the worst blockchain idea I've heard.
It's honestly not. But oh dear God.
Getting away from blockchain, I think for the future of open source, we have to make it easy to automate some of these validation processes, right? Because that's what can get us in trouble. Is if we don't have easy ways to apply security and verification methods, it will take away from I'm Paul, I want to throw some open source code out there. Like, whatever happens. If bad things happen more often than not, it will erode the trust of open source software. And that's something that I know myself and very many others do not want to see happen.
Yeah, like I say, it's where does it make the most sense to invest is the biggest challenge. And this is why, doing the surveys and figuring out which things are critical. And where do you put your effort on hardening the open source projects? That is certainly the Alpha Omega project is trying to really address that. And on the Omega side, for all the little projects that are out there, keeping lightweight touches, but working with various organizations to make dependency tracking available and GitHub and so forth. And so it's just sort of there baked into the ecosystem. The more of this type of thing we have in both directions, the better it's going to be. But it's a community. It's worldwide, right? We all have a little piece to play here.
It's interesting to think about how differently we could trust the open and free markets versus the closed markets. In other words, so I want your take on this, Kate, because I think it was last week we were talking about how you have the Apple App Store. It's a walled garden, and there's one central organization in control of everything inside of that walled garden. That actually has some really profound security implications in a positive way. Now, I don't agree with the walled garden and the one central control, so I want to go to open source, and I have a lot more freedom, but I lose that central point of control, which makes me more vulnerable to certain types of attacks. How do we balance these two things?
Transparency. To the extent that we can actually see what is in the code in the walled gardens as well as outside. Certainly, there's not a lot of incentive for those in the walled gardens to make things visible. I don't know the solution there. If the solution for adhering to the licenses, has never been a big one. If they think they can get away with it, they will, because it's business, right? Some people's minds, it's just a risk. Whereas if you're trying to do the licensing properly and follow the right things, okay, you will want to know and you will want to make sure you're adhering to the terms. So the security in the walled gardens, Cathedral and Bazaar, I guess.
Yeah. That's the reason why I like to use open source as well, is some of the things you're touching on, right? Is I want to be in control of my own hardware and software, and I want to use it longer than the main central control point wants me to use it for, right? I don't want to have to go get a new phone if I don't have to.
Yeah, or get a new update, get a new pay more money, things like that, right?
Yeah.
And so forth. These are all different models that are out there. People, but on the other hand, I know that my mother is not going to want to look at any of this stuff, and she wants something that she can figure out how to use and just use it, and it just stays safe.
There's an Android phone. I put Graphene OS on there. Graphena is the open source Android operating system. I'm hearing Graphene, right, is gaining some traction, right? I don't know if I give that to my family, though, to your point, Kate.
Yeah. So, if you're a knowledgeable user, you're going to take some risks because you're comfortable. And if you just want something that works and you don't want to have to think about it, you may go to, the Android Play Store or to, the Apple Store and things like that. And just, download the apps that you care about. They obviously have a vested interest and they are making money on it. So for them to they want to keep their reputation high because they want to keep making money.
Right.
Because if there's so many bad issues, that will hit their bottom line.
Yeah, it's interesting that the one thing that brought this up, Kate, was the namespace collision attacks that happen in the supply chain, and how the comparison that we were making was, if there's one central controlling point in organization, they can prevent and say, no, there's already something named this, you can't fake that, and they can essentially secure a walled garden. When we get to open source Python libraries as an example, we have that in NPM libraries, Node.js. We have that problem more often, and it's a much more difficult problem to solve than I had anticipated. Although I don't know if you know, efforts in controlling the supply chain specifically for namespace kind of attacks.
I don't bury too much into there because I mostly am hanging out in the embedded space.
Yeah.
Which tends to be nice and low level, and we have a very clear visibility as to what's going on. But I'm aware of David Wheeler is a really good person to talk to about this stuff. He's been studying a lot more than I have. And, they're out there, okay? The typos going, I run into it when I'm trying to do things in my own systems, no question. And, it's just be very careful and be very precise. And look at the hashes. What a concept. Right, double check your hashes.
They're there so we look at them, right, and not just skip over the warnings.
Okay.
Lots of good practices out there.
But that transparency, I think you're talking about, it is easier at the lower level. I mean, because the higher you go, the more noise and things start sneaking in.
It's more noise and things. Like I say, there's a lot of things that go into the embedded space, but there's a little bit more line of sight as to what is actually there.
Yeah.
And being able to, and you need it realistically.
Because if you don't even have
there, sometimes if you've got a vulnerability in something out there.
I mean, if your kernel's not even secured, you're already toast. So at the very least, that you need that lowest level to be 100% solid, and it seems like that should be doable to me because it is such a contained. I know it's difficult, but unlike say, I've just got everything here and I've got a whole operating system and all these apps, it gets so noisy and so complicated. But
so did you realize that there's 9 changes per hour that are going into the
Oh,
Linux
I
kernel.
know, but I mean, within reason. I'm saying, you've at least got a constrained space to work with, so there's
Wait,
some kind of control in place.
What are those stats?
Yeah.
How many? You said there were nine commits an hour to the Linux kernel. That's crazy.
Yeah, and Zephyr's been doing really well, and they're up to between 1.8 to 2 commits an hour now in that community, and so there's a lot of momentum and a lot of new features, new hardware. There's new hardware coming up all the time, and quite frankly, with the supply chain problems we have out there, if you have to substitute in a different part or a different driver or a different IP block, making sure that now works, things like that on these components. We're seeing a lot of that happening out there.
Did you guys have more questions about SBOM? I think there were some SBOM, SBOM related questions.
I have a question.
Okay.
And I have first a comment, or maybe it's another question, because from your ELISA medical devices working group, from the update that was done at the ELISA summit this year, I am curious how many of the hosts, and then by how many of our listeners, are familiar with the term soup. To describe it, and I want to understand.
I'm curious now too. I know I can tell you what it is, but yeah.
Soup is beautiful, and I use it to parse web pages. No, is that not? No, different.
That's
soup.
one type, but not this. Not this we're talking about in the medical device space. Good one,
I
Mindy.
think it's a fantastic acronym that needs to be known. It refers to the software of unknown pedigree.
Mm-hmm.
Oh, interesting.
Yeah. And realistically, the medical standards have ways of treating that. And so you can actually, and so it's a factor out there. But one of the other things you'll find is the FDA is really interested in making sure we can get SBOMs happening for things going forward.
I would imagine. I mean, that is such a huge part, and especially and I don't know if your group views it as that all Linux is soup, like if all Linux components are then soup, because
no. So what we're doing in the ELISA group, in the medical devices group right now, is we worked with OpenAPS because that was an artificial pancreas system, and what it does is it uses a Raspberry Pi to bridge the loop between a insulin pump and a glucose monitor, and to basically create that loop to understand what is happening with the insulin levels of a person's body in response to the environment affecting the person. And so that, by definition, is a critical system, because if you have put too much insulin, you've got problems, to put it mildly, or too little in some cases too, right, for type 1 diabetes. And understanding that the FDA has an FDA device for your insulin pump and an FDA device for your glucose monitor. But in the middle was you had to sort of rely on someone sort of, listening to beeps and doing work to calculate, do I change it?
I love the infographic that was it. I don't remember the gentleman's name on your group that made the infographic that showed all of those parts. And I think it really brought up like how critical it is in these very tiny parts within this huge ecosystem between the people and all of these different components.
Yeah. And like I say, they're using a Raspberry Pi to connect them. And that Raspberry Pi is running Linux. And so Linux is now part of that safety loop. Now, it is not a primary part, but it has to be interpreting the data. Things can go wrong. How do you do the analysis to make sure that, you're maximizing the safety for people? And so one of the things we're sort of looking at right now is we're actually doing the call graph tracing of the Linux kernel. And so we've got volunteers in the OpenAPS community who are running workloads for us and collecting tracing data. And then we're mapping it through the kernel to understand what parts of the kernel are actually being used. And so that mapping in the kernel lets us identify, okay, what are these critical flows that are being exercised, and taking the analysis down so it becomes so it isn't just soup. It really is on certain known paths. And we've got another group that's looking at subsystems of the kernel and looking at the architecture and the security implications, things like freedom from interference in the memory subsystem, like making sure one process doesn't have ability to see something else in another process. and doing a more detailed analysis of this type of work with kernel.
It was fascinating. Then I have another question, and it's more about kind of speaking to the effectiveness of the SBOMs. And
Okay.
I was wondering if you had any feedback, or if you know, so for embedded devices that do go through a critical failure or a safety, critical safety failure, for those with an SBOM to those without, how often are they able to get back to the exact build of the binaries or executables whenever they were released?
My challenge here is the fact that all of this stuff is under NDA and held very tightly by the device manufacturers. So, and we're just and they're just starting now to really adopt the SBOM and generation as part of the whole building it out. So I think we're in the early days. I think that question is a good one to ask someone from one of the device manufacturers who actually may have has more actual data insight. I would hope that they all have all the details of what they've built in, and they're keeping good records internally, because they probably do have to do some of this because they're going through the FDA, and the FDA is going to be having some oversight into this. But in order to put some of these devices on the market, but I don't have a good feel, and people just want to make it happen. So this is why the medical group and the NTIA working groups took the lead on really trying to prototype this out, because they wanted to make it happen. Like I say, everyone seems to want to try and make it happen, but make it happen in an effective and efficient way for themselves.
Kate, I had a question about the Linux kernel and security. How much does the Linux kernel team, because you seem to be kind of in tune with what they got going on today, how much do they rely on security researchers to get security improvements versus internally doing some of the security analysis? Like, how much happens internally versus relying on external reporting?
Remember, the Linux kernel developers are all people working at different companies. Okay, there's only 3 Linux Foundation fellows that are involved with the kernel. There is Linus Torvalds directly. There's Greg Kohartman, who does the LTSs, and then there's Shua Khan, who's doing a lot of work on the test infrastructure and mentoring and so forth. And Shua's actively involved in the tracing exercises we're working on in ELISA, and trying to help us figure out best practices and then get that upstream into the kernel. So, but a lot of the analysis happens by experts in companies like Google, Intel, AMD, etc. So we've got a lot of people out there in the industry, and they're collaborating effectively. I think they've got a group of security researchers that communicate with each other at the kernel level about the kernel. And then there's various conferences about Linux security where some of the ideas are put forward and discussed. And that happens a couple times a year.
I think it's an interesting aspect of our industry, right, to think about how many lines of low-level code represents that attack surface. And threat modeling that attack surface and proving an attack is, I feel like the number of people kind of gets smaller and smaller that can actually do it. And that's some of my concern, is that when you come through with your engineering degrees, you're starting to learn a lot of higher level languages, and there's not enough focus on the lower level code that can be really vulnerable. It has high privilege.
In fact, one of my colleagues in one of the groups' pet peeve is there really isn't enough system engineering that's being taught, and understanding, the system engineering concepts. Some of them are different than the sort of open source wisdom, quote unquote, and being able to understand things from a system perspective, and then, quite frankly, over a life cycle perspective. Not just, hey, I've just thrown it up and done, I'm walking away, whatever. But, oh, hey, I've got to support, this is going to have to be supported for 20 years.
Yeah.
Which a lot of our critical infrastructure has been the norm.
Yeah. And that the kernel is so beautiful, too, and how it provides that layer of abstraction so we can write more like human readable code when the kernel takes care of a lot of that low level things for us, but someone still has to code at that level.
Right.
And secure at that level, which is the
Yeah,
concern.
and that's why there's a very active group of developers and researchers in the various companies that were working with Greg and Linus and Shua and others in to make sure that what's there is is minimizes any known vulnerabilities. The vulnerabilities are addressed as soon as we learn about them, type of deal, and they're backported and available to people. So that people don't have to go and do that work themselves and track everything that's happening at that change rate.
And I have seen a number of different initiatives and changes that speak towards a much more secure Linux kernel in recent years. I think more so than ever before, right?
Well, yeah, there's a lot, like say, Linux is pretty much used in most segments these days.
Mm-hmm.
So there is a lot of desire to make sure it's as good as we can possibly make it.
But I do think you are gonna face a shortage of people who can actually develop and analyze at that level, because I have seen that over the years, and people calling, asking for students and things, and that's just stuff that most people are not doing now. Even if they use Linux, they're not into that old-fashioned stuff that we all used to do of, I'm going to compile my own kernel, and I'm going to mod my own kernel, and I'm going to do all these things. And they just say, oh, Ubuntu, it's just like Windows. I don't, because they're using it like an operating system, and they're not really focused on that. And I'm sure there's engineering programs all over the place that teach that, but a lot of them don't. I mean, that is
it's a lot. And so this is one of the reasons that the Linux Foundation's been putting up training. So we've got a lot of introductory training as well as training you can go after certification.
Yeah.
So you sort of have a way of learning about some of these basics. The other thing that we've been doing a lot of work in is actually having mentorship programs on how to contribute to the upstream kernel, how to work on it, the kernel and the tools. In the ELISA, we've got a tooling group that helps people with understanding how to work with these things as well. So,
and that's good. I wish more.
It's all ways to increase it, but I'd love to see more low-level programming happening at the university.
A lot of the people that got into that space originally were getting into because they had to get into it because they were working with things that didn't work, and they had to kind of make it work and all these sorts of things. And they learned it like a lot of us learned all kinds of things just by doing it and having to do it. And I don't see that as much anymore. I don't get as many students coming in saying, hey, can I compile Sarge and run it on this weird, Spark box or something? And because I want to do this. And now it's just like, I need an operating system. Which one do you recommend? And you're like, well, yeah.
Well, the thing is, like, the nice thing from Zephyr is I'm seeing some of that innovative side, because I'm seeing like people with wearables.
Oh, yeah,
like,
yeah.
LED shit. Like, one of the new products I just learned about over the holidays is a sound shirt.
I was going to say, I was looking at that. I was looking at the Zephyr products. I was looking at the shirt.
And you touch and you can play your music with your shirt, which is, I'd like I say, I'd like to get my hands on one. Let's just put it that way and play with it at some point. But people are doing a lot of really innovative things at that low level of integrating the sensors and the actuators together. And Zephyr lets them program to it, but it's also you have to build it yourself. And so, you can't just sort of, take a base and just
This is a completely unrelated comment, but because you said that, I was going to ask you, have you ever seen Drum Dance by Laurie Anderson?
Nope, haven't. Sorry.
Laurie Anderson still is a performance artist, and back in like the 80s, she had these clothes that were filled with microphones, and she did this whole thing where she played like a percussive piece, and the movements you had to make to play the piece caused you to dance in this very strange way, and it's actually really, really cool. And it was all being pumped through a synclavier, I think, and it was very interesting. Sorry, I just had to
No, I'll go look it up. It's sort of like the Ethereums too, where you're working with your gestures and gesture recognition, and you're playing from that side too. But there's a lot of really, cool things sort of emerging in this space, and we saw things that were sort of like just monitoring distance during COVID, some of the parts of COVID and things like that. And, we get to see rather innovative little things. One of the things I didn't get to CES this year, but I suspect that several of the products that showed up in CES probably have some Zephyr underneath it in the small space. So it's a bit of a research project for me. It's like, a detective, actually. It's a detective exercise to see where I can find Zephyr.
No, that's awesome.
I think probably more of the implantables too. I mean, both what
Yeah.
Dr. Doug
Well,
brought up.
that's why we need to get the safety up there, right? And know that
Yeah.
we the best practices in safety. And so we've got to. And for Zephyr, we're actually going through a more formal safety certification process and using the full V model analysis and using 61508 as our basis. So, having that requirements to code to testing traceability and being able to say that these are the principles we're adhering to and this is what's being satisfied. So we're trying to use Zephyr that way and did work on Zephyr that way. The Zen community is trying to do something similar. And then with the Linux kernel, we're sort of taking some different approaches because of the size.
Kate, I just have 5 questions left for you. Are you ready to play 5 questions with Security Weekly? There's no right or wrong answer. And it's just 5 silly questions.
Okay, 5 silly questions. Go for it.
3 words to describe yourself.
Lazy geek.
If you were a serial killer, what would be the weapon of choice? I don't see Kate like harming.
I have no idea.
It's really hard because I don't see Kate harming anyone like your entire life.
Like I
Cat. Kitty cat.
said, yeah, no. A supply chain attack, probably.
There you go. If you were to write a book about yourself, what would the title be? Innovation, where people aren't looking. What is your favorite hacker movie?
Blade Runner.
Choose 2 celebrities to be your parents. Can really be anyone.
Alive, dead, living, or fictional?
Yeah. Where I am in the age spectrum here, my parents are getting back into the pre-computer space to a large extent. Well, these 2 would never do it, but hey, Grace Hopper and Alan Turing.
Wow.
It's fantastic.
I applaud. Yeah, I
Yes,
applaud that one too.
very
That's
nice.
that. I wish that was my answer.
Kate, you are truly wonderful. Thank you so much for appearing on Paul's Security Weekly. It was great having you.
Thank you very much. Enjoyed myself.
Thank you. With that, we'll take a short break. Come back with the security news. Stay tuned.